solves the problem 3 from the Project Euler. It asks us to find the largest prime factor of the number, well, whatever it is, and it gave the example of, for example, 13,195. There's 4 distinct prime divisors of this number, but it wants us to return the largest one, which is in this case 29. So let's write a Python script for this to find the largest prime divisor of the given number. Here I have pasted a pre-made model of sieve of Atkins algorithm, which tests if a given number is a prime or not. So let's go down here. What our algorithm will do is to basically take the smallest prime divisor of the given number and divide that number with that divisor, and do this step multiple times until we end up with a prime. Well, the claim is that the number we end up with is going to be a prime, and it's going to be the largest prime divisor of the initial number. Because if it wasn't the largest prime divisor, then we would already been divided by that number during the previous steps. So we know that this works. So define largest prime factor, taking n, any number, as a parameter, for I in range 1 to n, but n is exclusive here and it's really important. You'll see later why. Now we'll test if this I is prime and if it divides n. So if n is congruent to 0 mod I, and sieve of Atkins, the prime test function, returns a true value, then it will perform the action of dividing n by I. So it will return this largest prime factor, the same function again, but this time for n over I value. As you see, this is a recursive function, and it will progress until n is a prime. So if n ends up to be a prime, then this I variable apparently cannot take any value that is prime and below n that also divides n. So we can just simply return n here. So if we print this value, the largest prime factor of this given number, which is 600, 85, 1475, 143, running it, we get float object cannot be interpreted as an integer. Well, we made a slight mistake here, I guess. Yeah, this n is, since we divide it by I, it's being a float, but we're interpreting it in the for loop as an integer, so we have to put this int before it. Now I think this should work properly. So we get this number 6,857. Let's put an answer here and check it. And it turns out to be correct.